Okay, AP Chemistry Chapter 2. Here we're looking at number 44. How many protons, neutrons are in the nucleus of these neutral atoms? So remember these atomic symbols. This is the mass number. You probably remember this. And the mass number is protons plus neutrons. And this number down here is the atomic number, or Z. Let's see if I can get a Z written there. And so this is the number of positive charged protons in the nucleus. So here we see 6 protons in carbon 13. And when I say carbon 13, sometimes you'll see this written as carbon 13. Where that mass number is 13. So there must be 7 neutrons in carbon 13 to bring our total mass up to 13. So you shouldn't have any difficulty with those. Let's move on to number 46. Same kind of problem we're looking at here. So you go here and go, 29 protons. What's atomic number 29? And you look at your periodic table and say to yourself, well, that is copper, atomic number 29. And the mass number is 65, so I can just put that right here. So that's what F would look like. So work your way through number 46. Number 48, what's the atomic symbol of an ion? With 16 protons and 18 neutrons. So let's see, 16 plus 18 is 34, so that's the mass number. Atomic number 16, that must be sulfur. And the fact that it has 18 electrons means it has 2 additional negative charges, more than 16 negative charges, so it has a charge of 2 minus. So that would be the symbol they're looking for here in 48. So you got to get really good at naming these kind of compounds or writing their formulas if you're given the name. So you should be able to just kind of look through this and go, oh, barium sulfate, sodium nitrate. Wait, what did you say? Sodium nitrite. So remember, this is how you're going to be tested on whether or not you know the names of the ions that you're working on memorizing this summer. So sodium nitrate, potassium permanganate, and potassium dichromate. Oh, and also you know that for the negative, the odd numbered problems in the book, most of them you can look up the answers in the back of the book. Have you discovered that yet? Number 62. What is the formula for these compounds? So remember, if you see these prefixes, we're working with nonmetal compounds, and those prefixes tell us how many. So boron 2 and oxide 3, boron trioxide. And when you're naming these, notice that there may be a better name for us to use than hydrogen acetate, because this is acetic acid. So you want to use the acid name for a lot of these that are acids, like sulfuric acid over here, G, sulfuric acid. Don't miss the names of those acids. So, lead phosphate here is E. Look over those carefully. Remember, you have to use Roman numerals for some things, and you have to decide what the charges would be. So I'm looking here at J right now, and I'm looking at that, and I'm going to call that tin. What's the charge of that tin? Well, it's a charge of 4. and so that would be tin 4 oxide. Also, we do have the International Union of Pure and Applied Chemistry to help name things in a systematic way, but we still use names like ammonia for NH3, not to be confused with the ammonium ion NH4+. So don't forget, we do use some common names often in chemistry as well. Number 70, you should be able to look and see what's incorrect about these names, like iron 3 chlorides. You've got to have a Roman numeral here. But these, for B, these are both nonmetals, so we don't use Roman numerals. This would be trioxide. So that's what they're looking is what is incorrect, or what would you do to name these correctly as you go through. Calcium monoxide. Now we don't need the Roman numeral because calcium only forms one ion plus 2 ion, and it's got a metal in it, so we wouldn't use this prefix, so just calcium oxide. Just aluminum sulfide, because we have aluminum there, that's a metal. Manganese. Oh, there's a couple problems with this one. Did you notice both of them? Of course, we have magnesium, which is a metal, and we've called it manganese. It's a pretty common mistake. Don't miss that. I don't know if I typed that wrong from the problem or if they've actually got two things that are wrong with E. So go work your way through number 70, noticing things like sulfuric acid is actually H2SO4, and HNO3 is nitric acid, not nitrate acid. So make sure you know these and understand that you're going to be using these all the time. You're not going to have time to go, what is that formula? It's just got to pop right out there like you were speaking a foreign language. Wait, chemistry is a foreign language. Number 74, here we're just looking at if you have this ion, how many electrons and how many protons are there. So we're looking here at iron with a charge of +2. So iron is atomic number 26, so there are 26 protons. So +2 means we have less electrons, more protons. So this will be 24. So if we write, since this is a positive charge, they said to combine it with oxide and write the correct formula like FeO for iron 2 oxide, or Fe2O3 for iron 3 oxide. Remembering that when you say iron 3, it's about the charge here, not the number of oxides. Let's see.